Good morning, this is Dr. Turner for Integrated Math 2. Today we'll be covering 7.3, which is looking at special right triangles. So in 7.2, we talked about how you can use trigonometric ratios, sine, cosine, and tangent, to find a missing side. Depending on what information is given, you would set up the problem and then use your calculator to find the approximate value. In 7.3, the title is Special Right Triangles. So we're actually going to be looking at two types of triangles where we don't need to use the trigonometric ratios because there's always a common pattern that exists between the sides. Those two special right triangles are going to be a 30-60-90 triangle and a 45-45-90 triangle, where these are referring to the angle measurements. So a 45-45-90 triangle is an isosceles right triangle that looks something like that. And again, it's an isosceles right triangle, so the two legs are the same length. Okay? There is a way to prove this, but because we're trying to condense and not do things in too much detail, what we're going to do is refer to each of these sides as L, typically in the book, in our integrated math book, but most textbooks will refer to those legs with a cursive L. The relationship between the leg and the hypotenuse in a 45-45-90 triangle is whatever that length is times radical 2. In a 30-60-90 triangle, again referring to the angle measurements of that triangle, here it's not an isosceles triangle. We have three different leg lengths. Now this goes back to integrated math 1. Remember that the smallest angle is always going to be opposite the smallest side, and the largest angle is going to be opposite the largest side, etc. But for a 30-60-90 triangle, when we go to look at these legs, because the legs are different, we'll refer to S as being the smallest leg. And because it's the smallest side, it should be opposite the smallest angle, so that's 30 degrees. This angle would be 60 degrees. And then to find the other two legs, again, there is a way to prove this, but the relationship is based on comparing the longer leg and the hypotenuse to the short leg. The longer leg is going to be the short leg times radical 3, and the hypotenuse is going to be double whatever that short leg is. So, based on this information for 45-45-90 and 30-60-90, if I have one of these special right triangles, given any one side, I should be able to fill in the other sides of the triangle. Now, it's easiest when we start out with the leg in the 45-45-90 or the short side in a 30-60-90, but I should be able to fill it out anyways depending on any side that I'm given. So let's first look at 45-45-90 triangles. So let's say I was given, and remember in geometry you're always going by the given information and the symbols, not that it's drawn to scale, especially if we're doing it on the computer here or by hand, but assuming that's a 45-45-90 triangle, let's say I gave you one side as being 5 centimeters. So I could ask you then to fill in the other two sides. Well, if the first side is 5 centimeters, it's an isosceles right triangle, so this would have to be 5 centimeters. And then based on the formula here, then the hypotenuse would be 5 times radical 2 centimeters. Now, it's important to pay attention to the directions. Typically, for an assignment that involves special right triangles, they're going to ask you to fill out what is known as simplified radical form. That means we want to leave that as 5 radical 2. If you are using Google or your calculator and you give me a decimal, but the directions asked for a simplified radical, then that would be considered an incorrect answer. So you want to leave it in simplified radical form. Back in Units 1 and 2, we talked about how to simplify radicals, so if you need a little bit of review, I would recommend going back and looking at those videos. Otherwise, this is what you do. You're given one side, you have to fill out the other two. So that's pretty straightforward, right? If I have any value here that's a leg, doesn't matter which leg it is, but if I'm given a leg, I get 10 inches, the other leg's going to be the same, 10 inches, and then the hypotenuse is that times the square root of 2. So those are pretty straightforward. Where it gets a little confusing for some students is, okay, let's say I have a hypotenuse instead of a leg that's given to me. Now, if the book or the instructor is being merciful, you might be given something, let's say, 7 radical 2, and say, okay, well, following the pattern, then that's just 7 and 7. That's pretty straightforward to fill out. However, if you are given a whole number for your hypotenuse, then that might take a little bit of work. So let's say I have 12 feet as the hypotenuse. Well, now I've got to do a little bit of arithmetic. In going from the leg to the hypotenuse, so when I started out with the leg and I was going to the hypotenuse, like in numbers 1, 2, and 3, I had to multiply by a radical 2. So if I'm trying to go the opposite direction, going from the hypotenuse to the leg, then I need to do the opposite. I need to divide by radical 2. So that would be 12 over the square root of 2. And while that's technically correct, remember that simplified radicals, we can't leave a radical in the denominator. So to simplify this, what you would do is you would multiply the top and bottom by the square root of 2. And we're doing that because the square root of 2 times the square root of 2 is 2. Now I don't have a radical in the denominator. And of course, anytime we can simplify a fraction, we need to. So the 12 and 2 I can divide to give me a final answer of 6 radical 2. And then because this is a 45, 45, 90, this leg would also be 6 radical 2. So again, if you need a little bit of practice on simplifying the radicals, go back to units 1 and 2 and look at those videos. Okay. For 30, 60, 90 triangles, similar process. Again, the easiest is when we start out with the short side. So if I give you, let's say, 2 inches for the short side, then the long leg, and typically they'll show you your angle measurements here, but if I'm given the short side, then the long leg is that times the square root of 3, so 2 radical 3. And the hypotenuse is double whatever the short leg was. So 2 times 2, hypotenuse is 4 inches. But just like in numbers 3 and 4, you're not always given the short leg. So sometimes it takes a little bit of arithmetic to solve. So let's say in number 6, again, sometimes the book or instructor will be merciful here. Let's say I gave you the long leg as being 9 radical 3. And I specify that that is the long leg because it's opposite the 60-degree angle. So in that case, you just have to divide by radical 3 to get 9 for the short leg, double it to get 18 for the hypotenuse. Not too bad. But just like in number 4, sometimes you're going to be given something that's not the short leg or the long leg and be asked to fill out the rest, and you'll have to use your rules of simplifying radicals. So let's say I gave you the long leg as being 10. So in number 5 and 6, to go from the short leg to the long leg, I'm multiplying by radical 3. So if I'm going from the long leg to the short leg, then I need to divide by radical 3. Just like we did in number 4, I can't leave a radical in the denominator, so I would then need to multiply top and bottom by radical 3, which gives me 10 radical 3 over 3. If you can simplify, you need to. In this case, we can't because 10 and 3 don't divide evenly. So this would be 10 radical 3 over 3. And then to fill in the hypotenuse, take that short leg and double it, 10 times 2. My hypotenuse would be 20 radical 3 over 3. I do need to emphasize here again that if the directions say to leave it in simplified radical form and you just use Google or your calculator to get a decimal value, it's going to be marked incorrect. If it says simplified radical form, you need to write it as a radical. That's it for today, guys. If you have any questions, please reach out to me. Otherwise, have a good day, and I will talk to you soon. Bye.